topic is experiential learning. Okay, and most of us have already heard about experiential learning somewhere or the other. No, nowadays we hear skill-based learning, experiential learning, multiple intelligence, competency skills. Like more things are there, right? And it is just a vast. Today we are going to just see a small bit of that. And before I start, I wanted to know, from your point of view, what is experiential learning? Yes, can I have some suggestions? Yes, ma'am.
Experiential learning is nothing but hands-on learning, which involves reflection on the student's part.
Very nice, ma'am. Excellent. Yes, ma'am. Super. And Purnima ma'am is right, very right. Can I have something else, or anyone else would like to share any other point of view? The same thing in a different way. You can just share your own suggestion or definition in your point of view. No problem. And are we doing experiential learning as a part of our curriculum?
Ma'am, it's learning by doing.
Learning
Yes,
by
ma'am.
doing. Yes, very good, very good. Yes, ma'am. And are we, see, it is actually, we are doing it as a part of our curriculum itself. What is it?
Through activities, ma'am.
Through activities. Very true, ma'am. Very true. Initially, when we studied, I don't know how about you all, when we studied, we have never heard a word like math lab. But now, we have a math lab where we have equipments and more equipments to even for explaining the abstract concepts, right? So experiential learning is already what we are doing. Okay, it is not something different. And now we are going to just see how we can improvise that. Okay, so yes, superb. Thank you for your wonderful responses. So next we'll move on. Experiential learning is the process of learning through experience, as Purnima ma'am said, as Sundari ma'am said, and as Satyabhama ma'am said, process of making out of a direct experience. So what we are, the child is going to undergo some kind of experience out of which they are going to learn the content or the concept. That is what. And learning by doing. I already got this answer. Okay, so this is what is experiential learning. So now it is at the outset. Now something deeply, let us see what is experiential learning. Now we have Coates experiential learning cycle, where we have 4 steps. We have 4 steps. The first step is concrete experience. That is nothing but doing, having an experience. Okay, reflective observation, that is reviewing or reflecting what we have done. Okay, and based on the experience, what is the observation. Okay, then abstract conceptualization, that is connecting the abstract concept to what we have done, to the experiment what we have done. Okay, then active experimentation, trying out for something else, or how to utilize that concept in daily life activities that way. Okay, let's see again. So Coates learning, my full screen is visible, right? Can I have a thumbs up? You have reactions over there. Can I have a thumbs up, teachers? Yes. Oh, thank you. So my full screen is visible. Thank you, ma'am. So Coates learning, again, we are going to see what is step by step. So as I said, 4-step continuous process for effective learning that explains how you learn through experience. So here we can start with any step. Okay, these steps are in cyclic process. The student can enter in any of the steps, but it should complete a full cycle. Okay, then only the learning process, the experiential learning process will be complete and the result will be fruitful. Okay, the learning is a process whereby knowledge is created through the transformation of experience. No, this is what, according to Cole, in 1984, he has given a wonderful explanation as well as a theory, which has these 4 steps. Okay, so before we go into, as my topic is experiential learning, I want you all to experience or to feel, okay, what is experiential learning? So I would like to share a small video of 3 minutes just to have an interest or to know more about the experiential learning. Just a minute, I have just shared the YouTube link about this experiential learning, and it is just the video is also again the same thing. Like right from from the birth of a child, okay, the various stages where the child learns to walk, starting from walking, talking, or doing things or something. Everything is just nothing but an example of experiential learning, right? See how we when we try to walk, the child tries to walk, it it will not walk all of a sudden, the first step itself, right? Correct, teachers? Can you all able to get the point?
Yes, ma'am. Yes.
And the same way, we have to keep trying. After certain stages, then the child starts walking, and it it is all and by experience, like how to stand, how to balance, all those things are there. The same way, when we learn cycling, okay, when we learn cycling, even when someone stand in front of you and they'll say that, see, this is what the cycle looks like. It has 2 handbags where you have supposed to hold it. You have to pedal. It is called as a pedal. When someone instructs you in such a way, just tells you without making you to drive a cycle, will anyone can learn the cycling? No, right?
No, ma'am.
No, ma'am.
Yes. So obviously, all these are examples of experiential learning. And basically, we teachers are dominant of women, where we cook, right? When we learn cooking, again the same thing. When we make some first dish, okay, when we make a new dish, first itself it won't be very perfect, or we have to add something, or there will be something missing. Okay, sometimes it will be good, but when you do second time or third time, it becomes very perfect, right? It will be more better than the previous one, the first one, right? So that is what is experiential learning. When we undergo, this is what, right? So here it is in the experiential learning, we are going to see what are the 4 steps and how we are going to use it for the mathematical concepts with example. Okay, so I'm just proceeding with the presentation over here. Yes, as I said, stage 1. Okay, stage 1, concrete experience. So the learner cannot learn merely by reading or observing. He needs to actively participate in the experience by feeling it with all the 5 senses. Okay, so see, when we talk about traditional learning methodology, where the teacher keeps on talking or the teacher explains them the concept, whereas here the concrete experience, in this, the child himself will be a part of the teacher learning process. Yes or no? Can you all get my point, what I'm trying to say, teachers? Here the idea is to immerse in the experience and learn. Okay, so, and I think that we have seen some real life examples for what is experiential learning. And the stage 1 is concrete experience, where the child himself will become a part of the learning process, and he do that activity. By doing it, he can feel, or he can understand, have a concrete thing. Like how we say to known to unknown. That is what is a very common methodology we usually follow. See, say suppose we are going to take addition for class 2. Even though they have already learned in class 1, we will not go and just write on the board like, okay, add these 2 numbers and write the answer. No teacher will say like that, right? So we'll start what is addition. We'll have a recall. So known to unknown. The difference over here is the child in class 1 will know up to addition of 100, up to 100, right? Up to 100 only we teach them. Over here we have up to 1000. So here the same concept has been applied to a little higher level. So this is how we move from known to unknown. Same way here, the concrete experience, the child will take a concrete experience from the known concept. Okay. Now stage 2. Stage 2 is nothing but reflective observation. Okay, reflective observation. The second stage, right? Where the learner reflects at the situation before forming any opinion. When the child, say, we will take the same example, addition, okay? When I teach the addition to a class 1 child, what I will say, addition is nothing but putting together. When you just say like that, and okay, so that's what you're going to add by counting forward, do it as such means, first of all, the numbers itself will be an abstract for class 1 child. They used to get confused within the numbers itself, identification of numbers. Okay, we can't always talk about the achievers, those who score good, excellent marks. We have to even concentrate on the students who need extra attention. So we are taking an extra mile, extra step to cover all type of children, right? So over here, this type of experience, like now when I take some abacus, okay, abacus is a MATLAB kit where we are going to show them when I add 4 plus 5. We used to put the abacus. I think so. Even Charamati ma'am already showed you how to use abacus, and she even explained the benefits of abacus, right? So that way, when we show the children how we are adding, how we are, what is addition, the concept, they learn, they themselves do and learn. So addition means it is putting together. Addition means it is putting together that way. See, when I ask them, see, we might start subtraction or move on to shapes. But again, when we recall addition, when I ask them, what is addition? Can I have the answers when you also might have come across the same situation? When we recall some chapters, okay, like addition. What is addition? If they ask, what would be the very common answer from the children? Teachers?
Plus.
Very good, ma'am. Excellent. Plus. When we ask, plus. That's all they would say. But actually, the conceptual answer is what is mean by addition? So addition means
Together.
Putting together. So immediately when I just show them the hand, then there will be a child who can relate it that it is putting together, right? So that is how we are supposed to make the children to understand. But these children, as very commonly they are very fond of just plus numbers. That's it. They won't take up the conceptual knowledge. But might be at lower classes they can survive, but at a long run, the conceptual knowledge, if it is not going to be up to the mark, they might lose interest towards the subject, slowly by, when the mark reduces for them, right? So that is what. And now here, reflection observation. That's what. When we use abacus, when we put the beads, now it becomes more. It increases the number. 4 has become 9 now after adding 5 more beads. So it has increased. So all these reflections. So what are the other words putting together? Is the keyword. Any other words we can give for addition? Keywords.
All together.
All together.
Combine.
In all.
Combine.
Combine.
Total.
Very nice. Excellent. So these are the keywords. When we will come to know, we might not have thought of that word, but the child will tell when they do, when they take up the activity and do, we can see that there are children who really come out with some of the answers which are out of the box. Okay. So now we'll next move on to stage 3, abstract conceptualization. Okay. See, like how we say the alphabet in English. Okay. Same with the alphabet in Tamil, the letters, right? Same way we have numbers. But how we introduce numbers to them? When I just go and write on the board, say for the kindergarten child, 5, how does it will remember? What we are supposed to do? How they
We
introduce?
show the objects.
Very nice.
Keep one object for 1 and 2, the same object for 2. Then we will slowly introduce the number 2 in a numerical method.
Yes, ma'am. Excellent, ma'am. The same way, that is what abstract conceptualization. That is, we are introducing, even though it is an abstract concept, they used to think it as symbols, right? But we call it as numbers. We have throughout the subject, we are going to have numbers. So that concept should be made very clear to the children. So that is what is the simple example I can give you for the stage 3. Same way, like how we started with addition. Here, the abstract conceptualization is nothing but here we can the learner creates a theories. What is it? Whenever he come across a plus symbol or sum, the keyword again, the answer, right? The answer in addition, we refer to it as sum. So all these, they have to explore. They have to learn through these kind of activities. It is not that just we'll give the abacus, let them do it. Just like that, they will put, okay, fine, we have done. No, we have to explain the aim of that particular activity or that particular experiment or some whatever it is, the process. It should be fulfilled with the correct aim, with the correct concepts, whatever the terminologies, vocabularies, okay, add-ins, the number that are added or called add-ins. So all these, at class 1, it is not necessary. But again, for class 3, when we introduce, or class 2, when we introduce, when we recall, we can just improvise, just extend the conceptual knowledge what we are teaching. Okay, so as we discussed here, stage 3 is abstract conceptualization. The learner creates theories to explain his experiences. In this stage, the learner gathers and analyzes the information and draws conclusion. This focus on learning by thinking. So now that here the child again thinks. Now first I had 4 beats. When I added 5 more, it has increased, and then final result, the sum is 9. The total is 9. Again, the words. Okay. So this is what we are doing here. It can relate. Just like that add means what we are doing here, putting together. That connection is done in stage 3. Right. Now moving on to stage 4. Stage 4 is nothing but active experimentation. Stage 4 is active experimentation. So what is active experimentation? This is the final stage, right? So almost we started with the concrete. Then we reflected on what we did, and we connected with the concept, with the actually what we have done. And now we are in the final stage where we got the skill and we can try it out for the new one. Okay, let the child try for another sum, like 2 plus 6, what it is, or let them, they themselves can create a sum and do it. So that is how we can ask them to take up, apply the skill, whether they have got it right. The concept has reached the child in a correct way or not. Okay. So these are the 4 stages. These are the 4 stages we have in experiential learning. And it is not necessary that we have to always start with the stage 1. If we go with the proper stages, it is okay. Sometimes the child might jump into any one of the stage, but it should be a complete one. We have to make the child to understand and complete the whole process, so that it will become a complete learning for the child. Okay. Okay. So here, just because we are done with the topic, that doesn't mean they learned it. Okay. See, we, not you or me. Okay. We generally especially maths, I would say, right? Compared to other subjects, maths teachers will be always on their toes, right? If we are going to have some sports day or annual day or something or the other, we all will be rushing and we will be worried only about the classes, because even if we lose even one period, and we know that we are going to suffer a lot, right? We might be asking the other teachers, yes, if you have completed, please give the thing. No, we can exchange all those things we will do, right? It is always, the maths teachers are always like that, right? So why is it so? We have a vast portion where, see, if we take division, there will be short division, long division with the quotient. Within the quotient, we'll have zero, special cases. There are so many things, right? It's not like other subject. We have one lesson where we complete the teaching of the lesson and then we'll give the notes. Then again, we'll start with the next lesson. Not like that, right? In one topic itself, we have various subtopics, and it also to be taught to the children in a very, we can't give slight importance or more importance for one thing. Everything should be because all are interrelated, right? So that way. But when we rush up or when we move a bit fast, you can see that there are always 10 children, 10 to approximately 10 children who are sitting that we would have completed the whole chapter, okay? But they will not even know even the basic thing in that basic term or something. You would have completed the whole multiplication chapter. When you ask what is the product of 5 and 7, they'll just blink, right? Have you come across this way? Yes?
Yes.
Can I have some other topic where, can you please give me some other topic where it is very hard for the child to understand, or some tough topic where the child, after even completing some experience, can anyone share of your experience, please?
I get confused between factors and multiples, ma'am.
Factors and multiples. I was expecting this topic only, right? Factors always.
And LCM and
yes, ma'am.
LCM and HCF too, ma'am. For 5th
yes,
standard,
ma'am. It is
have
related.
a lot of confusion. Whether it is 3 factor or L division, ma'am. What can we do it now, ma'am? Please tell me, ma'am.
In the last minute during revision time, they will get that too. On the last day,
yes, ma'am.
You please explain. Can you how to find out? Yes, ma'am. Very true, ma'am. Very true. And right. Very each factors has a set of properties. Multiples have a set of properties, and both will be contradictory. Where they have to remember a lot of things. So again, we have to take some other step, right? And usually, how much ever times you say for HCF, they will do LCM. For LCM, they will do HCF. That they will do correctly, right?
Yes, ma'am.
Yes. And especially the prime factorization. No, I have told the children, even though how much ever hint you give, they'll do the same, okay? But at least out of 10, 5 you can help them out by simple tricks or simple hints to remember. I have told them prime factorization they have to do for both. But how to do? Like HCF, we have to prime factorize separately. LCM, L, it starts, right? So I have told them big L. You put a big L, put all the, if they have given 2 numbers or 3 numbers, put all together and then prime factorize. So these kind of simple hints, somewhere we can just help the child out. Okay, fine. So we'll now move on to the next one. Yes. Yes. Now, experiential learning. It is not only that the MATLAB activities or MATLAB kits, what we do is the only way or the only strategy to incorporate experiential learning. Okay, we have various methods or various ways or tools to impart experiential learning. Okay, let us see what are they. First one is dynamic representation. Second one is reciprocal questioning. Third one is the pass procedure, communication and mathematical discussion, graphic organizers, and game-based learning platforms. And there are more and more, okay? You can even have a storytelling method, role play, or puzzles, quiz. There are many things. Now, today we are going to see these topics, okay, for experiential learning. Okay, why there is a need of these kind of various ways or tools? Why we have to use these kind of different strategies? Why is it so? Can I have some
different styles of learners in the classroom?
Superb, ma'am. Superb. Correct, ma'am. Very great. Okay, can I have some different varieties of learners? Can I get some answers? Any guesses?
Visual learners.
Auditory
learners, kinesthetic learners, and some students, they will, while reading, they will understand. Reading and writing learners.
Yes, ma'am. Very good, ma'am. Excellent. That is called as multiple intelligence. We call it as multiple intelligence. Okay. So we have kinesthetic, that is they are body smart. Okay. Linguistic, that is they are word smart. That is language part, they will be very strong. Okay. And the music smart. Music smart is nothing but where they are very good at music. They can learn through music. Okay, but we can't apply it for all the all sort of topics. We can't relate, right? But for the other subjects like English and Tamil, they can easily utilize these kind of strategies. And where we have kinesthetic, that is body smart. By doing they will learn. Okay, they have to work on it, then they will understand. So that way. And visual, obviously they will learn through the videos, or when they see, they learn. They have to see, and then they have to experience, they have to feel that way. Okay, so that is why we have variety of strategies or tools to explain the concepts. Okay, so that is why we are supposed to keep varying our style of teaching, adopt various methodologies or various tools to to attract all types of learners in our class. Our class is not only a class made up of one set of children. We have different varieties of children in our classroom, where we can't leave. Say suppose you are watering the plant, okay, in the garden. You are watering the plants in the garden. When you water, will you leave some plants? Okay, leave it. It need not be watered. Will anyone do like that? No, right? Obviously, no. So just watering a plant itself is the value what we give. The same way when we teach some concept, and especially when the parents come and say, as if they give high weightage to maths, right? High weightage to maths. The child would have got excellent marks in other subjects. But if that particular child has get less marks in maths, what would be the feedback from the parent during PTM? Yes.
They complain saying that maths, they are getting less marks. Maths man is not teaching properly.
Yes, ma'am. They will just give an open statement, right? They'll say that only maths she hates, or only maths she didn't understand. No, please do something. You have to do something and make her get. And sometimes the child would have been very average in other subjects, but in maths, the child would have scored very less marks. So again, they will say that only in maths is the toughest part for her or him, right? That is how they say. Because it is not only a new thing. Even previously, maths has been seen as a very important subject because it is a life skill, right? Starting from the morning when you wake up, the time, right? And the whole day when you deal something, even in cooking, we have measurement, we have ratio. Everywhere is mathematics. I would say that maths is a life skill. It need not be seen as a separate subject. It's a life skill. And each child must acquire mathematics, the skill of mathematics, right? And it is a very basic need. It has become a very basic need also. So over here, because of this, to we should not, no child should be left behind. Okay, whatever the concept we are delivering, it should be delivered to all the children. Okay, that is why we are following different strategies or tools to teach the concept. Okay, right, fine. We'll move on to the next one. As I said, the first strategy, dynamic representation. Okay, dynamic representation. So what is dynamic representation? It is a visual depiction of a mathematical object that changes in time, consistent with the mathematical properties of the object. Okay, so visual depiction or visualization of a concept. Are we doing visualization? Can you just reflect on the word visualize? Where all we use
the pictures like shapes.
Very nice, ma'am. Yes, ma'am. Correct. Very true. Shapes. Then, any other topics?
Clock, ma'am. Clock.
Yeah.
Clock. Time chapter.
Yes, ma'am.
That's
Very
showing
good.
the clock.
Clock. Correct, ma'am. Very true. Then,
Yeah, money too, ma'am.
money.
Money also. Yes.
Money. I'm expecting a very familiar topic which I didn't get till now.
Measurement.
Abacus, ma'am.
Pattern, ma'am.
Fractions. Measurement, again, my measurement is very true. And I expected fractions, right? Fractions without visualization. Fraction, no, we can't teach fraction chapter itself, right? Fine, very nice, very nice. Even we can say place value chart, reading a number, start. For everything we need some pictorial representation, right? Okay, here, moving on to this dynamic representation, here we are going to use visualization, okay? In that, how we are going to make it as dynamic? How we are going to make it as dynamic? Let's see what it is. See, I have taken a fraction example only. Over here, 3 plus 5 plus 1 by 5. This, even though it is a like fraction, without picture when I explain, the child might not understand it. They might just understand it as just, without the conceptual understanding. But when we explain this with the picture, he can visualize and understand the concept better, right? Yes. Now, here, once again, I just wanted to, here. So now here, if you take up, now, this is a static one, okay? Already I have kept the 3 by 5 plus 1 by 5 equal to 4 by 5. The activity has been over. This is over. Suppose, without doing this, without making out this, when after giving the same example, just I'm going to alter another one. Say, suppose I'm going to make it this as, I'm going to shade even this part, okay? I'm going to shade even this part. So, here the fraction becomes, now the fraction
5 by 5, 2 by 5.
2 by 5. Yes, 2 by 5.
5 by 5.
Whereas 3
5
plus
by 5
2,
is that.
5 by 5 will make a
Whole.
Whole.
Again, we can teach them that when we are going to have all the parts shaded, it becomes 5 by 5, that is one whole. So this is how we are building up the, we are extending the concept. We are making them to understand. When we take up one example, we are giving one more example and we are including the another concept over there, a whole. Okay. So it becomes it is what type of fraction now over here? When it becomes 5 by 5, what type of fraction is that?
Unit fraction.
No, ma'am.
It's a whole, ma'am. Whole. It's a whole.
It's a whole. So proper fraction, always the numerator will be lesser than the denominator. So it will be, the value will be less than 1. Over here, the numerator and the denominator are equal. So it has become 1. When the value of the fraction is equal to 1 or more than 1, it becomes a improper fraction. So again, here we are building up the concept. We are building the concept over here. Okay. So this way it has become dynamic representation. Okay. This is what is dynamic representation. Okay. Moving on to the second strategy. Okay. Second strategy, reciprocal questioning. Okay. See, when we say that experiential learning, it is just doing something and learning out of it. Is it so like that? Can it be an questioning from the question? We put the question to them and let them think and come out. Can it be an experiential learning when we follow this kind of strategy? Obviously, yes. Okay. So this strategy is nothing but is to create an open dialogue in which the students take on the role of a teacher and generate their own questions about a topic, reading section, or teaching a lesson or solving a problem. Okay, this is what. So let us see how it works. And it will be an effective one also.
Librarian of a school has 384 books to place equally on 20 shelves. How many books in each shelf? How many left over?
Yes, thank you, Sundari ma'am. Might be after giving this type of question to the child, first step, what the child will do. Just tell me as a child, okay, not like a teacher. They will try to make the word problem into bits and they will try to understand. But the very common error most of the child will do is by seeing the word left, what they will do?
They will do subtraction.
They will do subtraction. That's subtraction. All. Even though if you teach all 4 operations, that the child's priority will be only for 2 operations. What are they?
Addition, subtraction. Addition and subtraction.
Yes, ma'am. Either they will do addition or they will do subtraction. They will never try to comprehend the question and they will not do that, right? So, and there is a set of students who have a fear, have a phobia towards the word sums. Word sums, they will never attempt. Even they might score even above average also, but they will never attempt the word sums. There are few children, okay, to come out of these kind of situation or to bring out those children, to solve these type of questions. We have to put these type of word sums. I know that hardly we in one period we can complete 2 to 3 sums, but leaving the time constraint, if we spend some time in making the conceptual learning, make it as a discussion, when we put it like this, these type of questions, they will never forget. That is the basic difference between the traditional methodology and these kind of strategies. Over here, this question, when the child tries to read it out, first they will predict. They will predict. What they will predict? They will check what kind of operation to be done. Okay, what kind of operation to be done? Either it is addition or subtraction or multiplication or division. Then they will clarify. First, as I said, they will go for subtraction. But again, there is another word. These books to be placed equally on 20 shelves. There again, we are supposed to push, or there are few children where they will easily come out, ma'am, it is division sum, ma'am, right? They will come out. There are few out of 40, obviously 10 will be very sharp, right? So these kind of questions, when they learn together, when they themselves come out, having a discussion, and they will tell that, yes, ma'am, it is a division sum. Then what they are supposed to do? Why it is that? How many leftover is there? When we pose this question, what will be the answer?
The reminder will be the answer, ma'am.
Reminder. Why is it so? How it is subtraction and division are related?
So division is repeated subtraction only, ma'am.
Yes, again we are connecting, again we are recalling the concepts. So this one sum, when we make it like when we discuss, when we communicate, when we discuss these type of questions, we will get to know more opportunities to recall, connect with the previous topics, and also to how to proceed. The same way the child will also think in when these type of questions are asked in the examination. So that is what, right? So this second strategy is nothing but predicting, clarifying, questioning, and then summarizing. Okay. So first they will analyze, they will first predict what type of operation they are supposed to do, and then they will clarify whether it is apt for the question that is asked. Then questioning, in case they come across these kind of keywords, why is it so, how it is related with the operation, and then finally they summarize the final answer. Okay, so this is what is the actual strategy. So not only by doing we teach them the experiential learning, even these type of questions, discussions will also be an experiential learning for them. Okay. Now here we have the past procedure. Okay, right. Now, very often we have come to know that often they would have said like in a span, the usual average span of attention is nothing but around 15 to 20 minutes. Okay, for adults at least we can just have an attention span around. Span of attention is nothing but 15 to 20 minutes, but usually we have 40 to 50 minutes of a period. Okay, when we go at a stretch teaching them, this is what are factors, these are multiples, this is what we are doing, this factor tree method, listing the factors by multiplication, division, everything if we do, whether the child will be able to understand or to differentiate what we are doing actually?
No, ma'am.
No. Right. So here, this is what is the past procedure says. Okay, the intermittent strategic passes are needed to enhance the understanding of teaching materials. Okay, we have to give a pass. Okay, it is not that we'll just stop teaching and we'll say okay, we'll continue after 15 minutes, we'll continue in the next class. Not that way. Just 3 to 5 minutes of time where they discuss what we have done. Okay, say suppose if we are going to talk about geometry to them. Okay, for class 4 we are teaching about geometry, where we are teaching them the basic concepts like what is point, what is line segment, line, ray, how, whatever it is. Okay, it is actually theoretical only, right? And we are going to teach them, and after teaching all these, let them give give them a pass where I'll give you 5 minutes. Say, I want you all to list down all the keywords for each definition. Okay, or just write in your own words, what is a point, what is a line, the definition, or you see, let them see the book. Let you create the fill in the blanks. Just create your own questions. So framing questions will also make them to learn more. Okay, rather than just reading the answer, once they frame the questions, they will learn. No, it will be there. It will stay for long time in their memory. They will never forget that. Okay, so that is how this strategy works out. Okay, the passes are effective only when the activity that follows stimulates and facilitates to comprehend, reflect, and learn the material. As I said, we should not say that okay, today the class is over. No, there are 10-15 minutes. You can just make use of your own time, like just complete this and that. No, I will give you 5 minutes. I'm going to keep a quiz. Whatever I have taught, I will ask you a quiz. Okay, that way we should engage them. So that 5 minutes, they will not waste. They will discuss. No, just let them work in group or let them work it in pair. Okay, obviously 2 child will be sitting in the bench, right? So let them work in pair. Okay, or let them make a Venn diagram or a flow chart. Okay, a mind map. So all these, why not for mathematics we can't create a flow chart? Why not for we can't create a mind map? We can create, obviously. So that is how we are going to when we say something new, the child will obviously think, and they will have an interest to do that particular activity. So that is what is called as the past procedure a strategy. Okay, I hope it is okay, right? So we can have it as a pair review, or framing questions, or let them, I'll call on each one of you to tell about what is the definition, how we define line, what is the difference between the line and the line segment. Okay, so all those things we can ask, or note taking. We can ask them, just give me a definition or the points, important points, what you have noted down. That way we can give. Okay, so next we will move on to communication and mathematical discussions. Okay, so here the students will immensely benefit from a communication-rich mathematics classroom, and modes like presentations, journals, discussions, and cooperative group work will aid in their concept understanding as well. Okay, so here this will help out immensely for the achievers. Okay, the students who have more interest towards the subjects or no, and even the slow learners will be also benefited, because when we keep discussing, when they also become a part of this discussion, they will also have more knowledge, or they will have the interest to be a part of it. So that is how. And let us see what are the two type of communication we can have it. Here we have oral communication and written communication. So when we come across oral communication, here I have an example question. Okay, how would you classify the following figures? I want a response from you all. Yes. How would you classify the following?
Open figure and closed figure.
Open figures, closed
Figure and
figures,
closed figures.
Okay, then
Cover line.
figures made of straight lines.
Open
Yes.
curve.
Yes, ma'am. Open figure, closed figure. Figures made
And
up of
figures made of straight lines.
Straight line, slanting
Polygons.
line.
that is nothing but classifying the polygons, right? So with just one kind of picture, we can make many more, right? We can come out with many more classifications. So when you give questions like this, when the children, even they will come out with many creative answers, or they will, from that they will explore more. Okay, they will think out of the box. That is what I'm trying to say over here. Okay, this is for oral communication. And then written communication. Yes, again, here we have a question over here. Can I have a volunteer to read the question?
A
Yes,
bottle
ma'am.
contains half liter, 5 glasses of juice of 65 ml each was taken out. How much juice is left in the bottle?
Yes, ma'am. So here, thank you, ma'am. And can I have a common mistake done by most of the children when they do this kind of sums? What will be the common mistake done by them? Actually, it is a two-step problem, right?
And 65 ml quantity, ma'am.
Yes, ma'am.
They may not understand 65 ml quantity.
65 ml. Very true, ma'am. Very true. And 5 glasses of juice of 65 ml each was taken out. So again, that they will miss out, right? Again, here it is a two-step problem. The first step is to
Understand that half liter is 500 ml.
yes, ma'am. Superb. Half liter, that is a fractional form. They have to first convert it into 500 ml. Then
You want to multiply 65 with 5 to get the total ml, then you have to subtract with 500
subtract. Excellent, ma'am. Excellent.
ml.
Right, ma'am. Again, it is a two-step problem. That is, first is multiplication, then it is subtraction. Where here the conversion, conversion of half liter to 500 ml is also very important. So here 2-3 operations or concepts are combined together. So when we discuss these kind of questions, as written communication, or first let us orally also discuss it. So the child know what step has to be done and where he is going wrong. When they write on their own, first let them try. So we can point out that where they are going wrong first. They themselves will introspect the mistake done by them, and then they will come out where, how to proceed, what is the step that way. And I just thought of showing you the pictorial representation. Ma'am, mostly my point of view is, mostly wherever it is possible, make it as the pictorial representation. Here we can just draw 5 more classes. We can show them here 65, 65, 65. That is nothing but these many 5 glasses are taken out. So obviously it is repeated addition is nothing but multiplication. That is why we are multiplying. So that way, it will just hardly take 5 minutes to explain with the pictures on the board. It need not be a very beautiful picture. We can just go ahead with the rough pictures. Let them understand. So when we put it in a pictorial way, the almost most of the children will understand. We saw, right? There are variety of children in our class. So let them understand the concept better, right? Fine. Graphic organizers. These are visual thinking tools that makes pictures of your thoughts to help understand and remember information better when ideas, words, and concepts are associated with pictures, diagrams, charts, and maps. Again, here it is also related with the pictorial representation only. So it is again a visual thinking tool. And this common, this one, most of them would have done, right? HCF, LCM, Venn diagram, we used to show the children. And it can be done as an activity also, MATLAB activity. And as I told you, mind map or flow chart, these kind of chart, okay? Usually when I teach them measurement, what I used to follow is, just I'm sharing with you. If you have any interesting experience, I'm very happy to hear from you also. What I do is, when we take up a measurement topic, they will know, half of the class will get confused where to use which unit. Okay. For liters, for capacity, they will use gram, or even meter, kilometer also they will use. It's because the lack of conceptual knowledge. Okay. So they have to remember. So what I will do usually, this kind of flow chart, right? First I will write measurement. Then below I will put 3 lines where we'll make it as length. Okay. Then capacity, then weight or length, weight, capacity in order. Then under length, obviously for class 3 or 4, we are not going to take all the units, all the standard units, right? We are going to just introduce meter, centimeter, kilometer. So those 3 you write. Just write a keyword for short length, centimeter, longer length, meter, distance, kilometer, just a keyword. So let that be one full page. Let it be like a mind map. So when at a stretch, when the child wanted to recall, they will know. Same way under the weight, gram and kilogram. Okay. So for lighter object, just write lighter object. Just write heavier object. So these kind of map will help them out to understand the concept better, for which unit what we are learning. Okay. So that is what these kind of things will help them out. Okay. Just thought of sharing with you. Would anyone like to share any interesting experience or where you have used these type of maps or flowcharts for any other topic? Okay. If any of you remember it, later also you can just share with me. Okay. Game-based learning. Game-based learning. Okay. So what is game-based learning? The name itself says, when you say, I'm going to conduct a game or just even a quiz, the whole class will become very active. They will shout, yes, ma'am, yes, ma'am, yes, we are ready, ma'am. That is how, even though the child who scores very less or very has less knowledge towards this subject, even that child will be very active, very happy, very enthusiastic, right? So game-based learning ensures high degree of student engagement and motivation, ensuring concrete concept understanding. Okay. So it helps the child to motivate. They enjoy the game, right? But it should not just be the game alone. We should have to, it should be related with the topic. Okay. So I would like to just share a few points, few games for class 1. When you introduce the lines, okay, they often get confused between standing line and sleeping line. Especially standing line, sleeping line, they know by the word. But when you introduce the word vertical and horizontal, they have a confusion, right? Yes?
Yes, ma'am.
Yes. So that time, when as we enter into the class, we have to do some warm-up exercises, right? So that way, when what we we can do is we can just ask them to show using the hands, okay, like vertical, horizontal, slanting. So I used to tell, not in a very orderly way. I'll just give them like horizontal, vertical, slanting, horizontal, slanting, like that. So they have to do the actions. Like how we initially used to do warm-up exercise, like stand up, hands up, down, all those things, right? Opposite way, all those things also they will enjoy. Now here, this will also make them to remember what is vertical, what is horizontal, what is slanting. Okay. And the other way, I hope you all have come across ping pong for multiples, common multiples, right? Ping pong. Right? I hope most of you would have done that game, right? Ping pong, multiples.
Yes, ma'am.
Yes, ma'am. Fine. And same way we have Pictionary. 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 Yes? Or shall I just explain what is Pictionary?
Yes, ma'am.
Yes, ma'am. I'll just show you. See, we used to play Dumsharus. I hope everyone will remember Dumsharus, right? So this Pictionary is nothing but using pictures. You're supposed to, give hint to the other group. Okay, we'll call out. We can just, as usual, like quiz. We can split into groups. One will be coming out, and we'll just tell them the word alone. They have to. They can give hint like, no, it is going to be these many letter words. Okay, let I give you. Fine. Yes. It is not related to math. I'm just giving you in general. Okay. Yes. Okay. This is going to be the word you're supposed to find out. So how many letter word is this?
5
Nine.
plus 4, 9.
9 letter.
Nine
Yes.
letters.
9 letter word. I'm just splitting up. I'm just breaking up the word into 2 parts. Okay. I'm going to draw over here. The first one. What is this?
House.
House.
Boat.
Yes, ma'am. House.
Houseboat, ma'am.
Boat.
Okay.
Boat.
This
Houseboat.
way you can just give the same way mathematical concepts. Okay, mathematical concepts. So over here, let I do. Okay, once again. Now it is a math concept.
Shapes.
Shapes. Can you please be precise?
Polygons.
Polygons. Excellent, ma'am.
Polygons.
Polygons. Okay. Here you can just ask whether circle will also come under polygon, why or why not. You can just make it as a discussion, and the child will again know. It will be an extended learning. They will know the concept will be again. We are recalling the concept, so it will be more clear that circle, since it is even though it is a closed figure, it is made up of a curved line, so it will not come under polygon. So these kind of extra points, again, key point, we have to stress it out. So that way they will do. So this is what is called Pictionary. Parts of a circle we can play like that, ma'am. Radius, we can just ask, what is this? What is this? Why not the chord is a diameter? But the longest chord is
Diameter. Ma'am. Diameter.
Yes, ma'am. So these kind of concept-based learning can be done, and it will be very helpful in the same way that it will be interesting, okay, as well as the child will also understand the concepts. They will remember, not understanding, they will remember it very well. Okay. And it all can be asked in objectives, right? So that way. So now we'll move on. Why experiential learning? Okay, why experiential learning? So experiential learning accelerates learning. Okay, so repetitive learning or learning by rote has long been replaced by learning by doing. It involves critical thinking, problem solving, and decision making to deliver a training module. So when we saw many examples itself, we can understand that the experiential learning totally differs from the the traditional way, where it make the child to think a lot. Okay, when we have the discussions like for the word sums, they they even apply it in the real life. Obviously, addition, subtraction, multiplication, division, when they go for shops, they are using it. So there they will apply. Okay, so all those things are the points under accelerates learning. Moving on to the second point, provides a safe learning environment, right? So what is it? So here, as a part of experiential learning, and they can even use real life scenarios that depict several challenges which a participant will eventually face after the course completion. Yes. See, when we discuss, one of you gave the example as money, right? When we talk about money, when we can have a shop scenario, it is a general thing where all the teachers will do for money chapter, and that is nothing but, even though it is a very usual thing, which is a very important skill in life, right? They are going to apply those things in real life. So that is what is over here. So we are providing them a better learning environment compared to the usual methodology. Now, why experiential learning? Again, the third point, bridges the gap between the theory and the practice. Yes, obviously, when we just, like, let's say, when we introduce a concept and do sums, division is nothing but, we have two methods. Short division, long division. Short division, we use tables. Over here, long division, you have to take the hundreds place, this, that, all those things. But what is division? What is division? So sharing equally or making equal groups leads to division. So you can just, explain it with the native games like Pallanguri, or if not, they can even use the ice tray and, some rajma seeds or something. So even, chennas or whatever it is. So all those things, when they put it one by one, they are repeated subtraction concept will be coming in, and the terminologies we can do. So all these, they are learning by themselves by doing. So the gap between the abstract and the concept, concrete knowledge will be filled, right? It will not, it will bridge the gap. That is what. And the fourth point is nothing but produces demonstrable mindset changes. Okay, so the mindset, what is, most of the children has less interest towards mathematics because it is abstract. But when we do these kind of activities, they tend to create interest towards the subject. They themselves will participate actively. That is what. These are all the benefits of experiential learning. And in comparison, experiential learning with West traditional learning, over here, we can just easily, have a glance at it and we'll move, because 4:15 the time. I thought, I have, yes, only few more slides. So experiential learning and traditional learning. So here, and I wanted to recall one of the teaching methodology which Shobana ma'am took, right? Can I know where experiential learning comes under what type of methodology? What type of methodology, teachers? Experiential learning comes under?
Student-centered approach.
Very nice, ma'am. Excellent, ma'am. Student-centered teaching methodology, right? So here, the traditional way is teacher-centered, whereas here the student himself is experiential learning is nothing but the learning from experience or learning by doing. Whereas the traditional learning is nothing but learning theoretical concepts without relating them to the real experience. Yes, right. So that is what is a very big difference, I would say. Then the second point is learning may not take place in the classroom, whereas, yes, no, when we take them for at lower level, we have odd numbers, even numbers. Just like that, we can take them out of the classroom. Let them stand, no, in a circle, okay, or the way how you want it to. Just ask them to say the numbers 1 to 40. Might be 40 children. Usually there will be 40 children in a classroom. Now you just instruct them odd numbers. The numbers who took odd numbers move a step forward. Okay, even numbers hands up, like that. When you do the odd even concept, it will be a playway method again. And same way here, you can just tell them to stand in groups as any number randomly and ask them whether it's an even number or odd number. How to make even number or odd number? If we are able to put it in pairs, it is an even number. So these kind of words, even multiples you can do in this way, right? You can even draw the number line and you can ask them to jump according to the multiple. So it need not be always experiential learning, need not happen in the classroom itself. Okay. But here the learning takes place only in the classroom. Okay. And here, moving on to the third point, learning through observation, reflection, problem solving, and creation. So all these are being different process where the child has been involved. Whereas here, learning through assimilation, practice, and reciting. Just the like rote memory. They just memorize the steps. This is what it is going to be, multiplication or division or factors. Whatever it is, this is what is going to happen. But they don't know the real essence of the concept in mathematics. Then the last one, the instructor passes much of the responsibility on to the students. Whereas over here, traditional learning, the instructor focuses on providing instruction and teaching for exams. At the exam point of view, the usual traditional way will be concentrating more. Whereas here, the conceptual knowledge, okay, of the subject has been concentrated more. Here we have some more points. Students may have to identify the knowledge they require and then acquire it themselves. Here the student, it is similar to inductive method, that is investigation method, they would say. Like they themselves will come out with the solution, or they will reflect on what has been acquired. So that is what in experiential learning. Whereas here, the students have to study a clearly defined curriculum. Okay, this is what is the thing. They have to just follow the instructions. Whereas over here, the next point is students manage their own learning. Whereas here, the students are told what to do and when to do. Okay, the instructions are given and the students are just following. Whereas here, the student himself takes an active participation. Moving on to the third point in the slide, mistakes are embraced. They are regarded as opportunities to learn. Obviously, many of the child will make mistakes, right? When they do the activity, even when we take up the math lab activity or activities that we do it in the lab notebook, there will be errors. Obviously, see, we should not judge a child just only the based on the presentation. No, it should be the way how the child has taken the concept, whether it has reached the child or not. That is what is the main aim of the doing an activity, right? So here the same thing they are saying. Whereas in the thing, mistakes are forbidden in learning. The traditional way, it has been forbidden. It is not used as an opportunity. That is what is the main difference between the experiential learning and the traditional learning. The last point, students are likely to get intrinsically motivated, whereas the students are likely to get extrinsically motivated. Intrinsically means they themselves get self-motivated. That is what is the difference. Whereas here, the parent or the teacher has to push the students to learn. So this is what is the main difference between experiential learning and traditional learning. And as we already discussed benefits of experiential learning, almost we have done. Okay. So I'll just, can I have an volunteer to just read out the point wise? We have 4 points over here. Yes.
Yes, ma'am.
Yes.
So, benefits of experiential learning. It offers opportunities to students to think freely and operate differently without losing their confidence. Builds ground for self-motivation and exploration. Learning by experiencing is far more effective and long-lasting.
Yes.
Builds competency skills.
Yes, ma'am. Thank you, ma'am. Thank you so much. So I hope almost all these points we have discussed with when we discussed the example. So I may not know again explain the same points, I think. So we'll just move on to the slide summing up. Okay, summing up all the what is experiential learning. We'll just have 3 subdivisions. Okay, experiential learning is a pedagogy, right? It is a kind of methodology, or it can be a tool for what? To make educational environment student-centered. Okay, as one of the teacher pointed out, it is a student-centered type of methodology. And here, let students control their learning. Okay, they themselves explore, they themselves learn, they themselves come to a conclusion and learn, right? Whereas the third point is enable students to think critically, evaluate, make decisions, and construct. Everything is there. Yes, all these we have explained. We have already discussed. Then make learning experience cooperative, collaborative, and independent. Yes, when we do, when we conduct these kind of activities, so sometimes it may be a teamwork, it might be an individual work. So all kind of students are being involved, and when it is a teamwork, they cooperate. They know the communication, the collaboration, everything will also be developed, right? And bridge gap between theory and practice. Already we discussed this point. And what should not be the experiential learning? What is not experiential learning? Simply doing too many activities in a class, just like that. When we do many activities, say suppose for decimal form, I'm going to ask the children to express it in a graph paper or a grid sheet. But when I just tell them, say 0.12, okay, I'm going to ask them to make 10 cross 10. Take a grid of 100 squares, okay, and just color 12 of it. That's it. Is it so that like that? Will that be the aim of what I'm doing it? I'm just representing the decimal number in a pictorial form, right? So I should say the fractional form. What is nothing but 12 by 100? Which is equal to 0.12, and the places, it is 10th place, 100th place. Why is it so like 10th place? Why is it 100th place? Yes or no, teachers? Can you all get what example I'm giving it? So it is not just like that. It is not doing simple activities. We should know the aim of the activity. What should be the specific learning outcome? Okay. It should be very clear. It is not just, like that. Since I have to do the activity, I am just doing an activity. That should not be the, that will not fulfill the experiential learning actually. That is not the right way to do, right? Now, taking students out for a visit without any specific learning aim. So this is not an experiential learning. Experiential learning, just like that, taking them for a walk. Okay, let's just look at the things. How can you relate? No, without any aim. We should not supposed to do. Right? And same way, utilizing expensive resources for learning is not necessary at all. Or no, we should not ask the child to just look into the videos and come, or no, you just check it out and come. The videos are there. No, videos are available in the internet. You can just browse it. So all these are not necessary. That is not an experiential learning, right? So that is what. And what else it is leads to? That is what we know. We already discussed: accelerated learning, safe learning environment, change in mindset, increase the teamwork and collaboration, promotion, retention, and learning beyond the classroom. All these we saw almost in the benefits of experiential learning. So this is what. And I have a last slide. One second. Yes, over here. So can anyone read the example over here? The question.
Averages. Example, Ram does the voluntary work by teaching children in an orphanage. The following table shows the number of hours spent by him. Find the average number of hours spent by Ram.
Yes, ma'am. Thank you, ma'am. Thank you so much.
You,
over here, average is a topic. Actually, when we just go with the formula, right? Sum of the quantities by total number of quantities. That is, we are supposed to divide the sum by the number of quantities. That is what. But most of the child, even though after you complete the whole exercise, they used to come and say, ma'am, average I can't understand, ma'am. Average I can't understand. Have you come across this way of output from your students? Yes. Or the students will understand and just like that they will do? Mostly they haven't, like doing the sum, they might do it using the formula. But understanding the concept, that's a change between the understanding and just like that doing, by using the formula. That is different, right? Now, here, for the same question, can we use visualization? That is what I have given in the next tabular column. Can you relate the both the tables, teachers? Yes?
Yes, ma'am.
yes, ma'am.
So here, yes, ma'am. So here what we are going to do, we are using visualization, a dynamic representation where we saw on the first point, right? So here what we are going to do is, without adding and dividing, how can we, by rearranging, we have to make the child to understand. How can we do that? So here, we are going to have, on Monday, the Ram has spent 5 hours. And Tuesday, the Ram has spent 2 hours. And Wednesday, 1 hour, Thursday, 3, and Friday, 4. For each hour, I have just used a circle over here. Okay. Now, what I'm going to do is, I'm going to rearrange the hours in such a way that each day, the number of hours are going to be equal. Okay. I'm going to rearrange. So, what I'm going to do, here I have 5, right? So, I'm just placing it one by one. So, see to that, I have to make it equal. So, here it is 3 and here it is 2. And here, the last one, Friday, we have 4. So, this green, I can just place it over here. Right? So, now it has become, what do you observe from this?
Same hours or equal hours?
Equal hours. Every day, there are 3 hours. Yes, ma'am. So, it has become equal. So, this is what we are doing. What we are doing over here, actually using the formula, we are going to add up all the hours and we are going to divide it by 5. So, the total hours is nothing but, what is the total hours?
15, ma'am.
15. We are going to divide it by 5. So, it is 3. The same thing we have done over here. Now, we can just explain the same concept using these kind of activities. We can use even counters, or even here also we can use beads or rajma seeds, whatever it is. Just even in coloring, just drawing and coloring. If you're going to draw and color, you have to use another tabular column. That's it, right? So by these way, they can understand the concept better, right? So I just thought of sharing you this example. Can anyone share your own experience where you have done an activity or some sort of experiential learning apart from lab activities? Can anyone just share your own experience, please?
For drawing a circle and its parts, we have taken the children to the ground and we will use the stick and the rope. They can draw a circle from the center. So from that, the child knows radius, diameter, chord, everything doing by on the ground, ma'am.
On the
So
ground.
that's the activity we have done for the parts of a circle.
Excellent, ma'am. Excellent. It is an experiential learning. Very nice, ma'am. Superb. Anybody else? Thank you, Purnima, ma'am, for sharing.
Namaste, Sumati, ma'am.
Namaste, ma'am.
Just I like to share for conversion. I did this, ma'am. Just ask the children to open the index finger and the middle finger of their left hand.
Yes,
they will open. And for conversing the higher to lower and lower to higher, there will be a confusion whether to multiply or a divide. That will be a big confusion. So I will be telling to draw the index finger multiplication sign. And the middle finger, they have to draw the divide symbol. So when the question was posed that convert into centimeter. So 3 meter. So what is given, what is asked. So meter is higher or smaller and centimeter is higher or smaller. They have to choose the figure. So, so meter is asked. They have to convert to centimeter. So meter is higher. So they will keep the another finger. They will look at the divide symbol high, tall finger, because it is higher. So they represent the tall finger.
Yes.
So from there they have to go down to the little finger. So in the already the index finger we have drawn the multiplication symbol. So from they will be seeing from there to there. When we want to come, we have to multiply. So 3 meter have to be multiplied with 100. So it will become 300 centimeter.
Correct. Very nice.
So the same way for the kilometer, if it is asked and 5,000 meter is given, they have to look from the lower to the higher. So from lower to higher finger, they will point out the divide symbol. So they have to divide there. So here they will not get confusion of dividing and multiplying.
Very good. Very good. Excellent.
This, they don't have a confusion.
Oh, very nice. Very nice.
Better. Okay, they understand better now.
Correct. Very nice, ma'am. And the same way we follow using actions, ma'am. Very nice. Thank you, Shanmugapriya ma'am, for sharing with us the new idea. And thank you, Purnima ma'am, also. What we used to do is, big. We used to show the hand like this. Big to small, multiply. So when we do the action itself, we will make it as an into sign. And smaller unit to bigger unit. When we do like this, it is division, we used to say. Small to big, we divide. And these are the few hints we can help the child, as Shanmugapriya ma'am told. Now we can, when we do like this, the confusion will be reduced. The mistakes can be reduced, and the child will easily remember in the exam point of view. The conceptual knowledge as well as an exam point of view also, they will not do mistakes. Very nice, excellent, ma'am. Anybody else would like to share?
Yes, ma'am. Whatever action you have shown, the exact thing I used to show to my students. From smaller to big, it's like that. And what Shanmugapriya ma'am has told, it is also very good, ma'am. We can try that also.
We can try that.
So it will be very easy. Yes, ma'am.
Yes.
And
same way, I would like to share one more thing. Like for decimals, since we related with the measurement, even for decimals, where to multiply, when we multiply, how the decimal point moves. When we divide, how the decimal point moves. So again, there is a confusion, right? So what I used to say to the children is, Mr. Deepak Lal. Mr. Deepak Lal, we just, when we discussed, we came out with the name, Mr. So multiply right. M-R, Mr. So M-R, M multiplication, move towards right. That many zeros, you have to jump towards right. Deepak Lal. So D-L. Mr. D-L also you can just say in short. It is nothing but division towards left. So that way we can just give simple hints here and there. Will help out the children to remember things easily. That is what. Okay. So I hope a lot of sharing has happened today's session, and I hope whatever I have shared will be useful for you. And since the time is up, I don't want to make it so delay, and we'll just end it up with the quote. Experiential learning is equivalent to personal change and growth. That is what was said by Carl Rogers. So he's as he said, as a human being, everyone has a nature to learn by doing things. As a teacher, our role is to facilitate the situation for every child to learn. Okay. So that is what is the ultimate aim of this session. That is what is the aim, what I thought of sharing you all.